music, science. It's the Amoeba People Podcast.
Greetings and welcome to the Amoeba People Podcast, the show where science and music collide. Of course, collide is a bit extreme. It's really more like a near collision, like an asteroid passing between the moon and the Earth, but not actually hitting Earth and resulting in mass extinction. Instead, just putting on an incredible show for everyone below to gaze at in amazement. My name is Ray Hedgepeth, the singer-guitarist of the improbably nerdy science rock band, the Amoeba People. And today, ladies and gentlemen... No, that's not the soundtrack to Plan 9 from Outer Space. It's a theremin right here in studio. Whoa, I waved my hand at it too closely and it keeps speaking. Whoa. You know, we figured, hey, this is a science podcast, and how in the world is a science podcast going to have a Halloween episode? Because do the two really go together? But we thought, you know what? We can bridge that gap with two things. A theremin. And today's topic, mass extinction. That's right. Today it's all about extinction, specifically the KT extinction that obliterated the dinosaurs 66 million years ago. And today's guest, you guys, oh my gosh, we are so thrilled to have the dynamic, incredible, inimitable Dr. Kirk Johnson, the director of the Smithsonian's Natural History Museum in Washington, D.C. I know, we can't believe it either. You know, the Smithsonian Natural History Museum is the most visited natural history museum in the entire world. The entire world, you guys. But mentioning Kirk Johnson's name in relation to the Smithsonian is kind of like, you know, saying Dave Grohl once played drums for Nirvana and neglecting to mention his years writing songs and performing with Foo Fighters, or his work with Queens of the Stone Age, or the countless other albums that he's played on, or even his hilarious role as Satan in the Tenacious D movie, The Pick of Destiny. Yeah, Kirk Johnson is the Dave Grohl of paleontology. He's written a bunch of terrific books, authored and co-authored numerous scientific papers. He's appeared on a number of PBS Nova specials, most notably the three-part Making North America, as well as a brand new Nova special called Polar Extremes coming out in February of 2020. And Kirk Johnson, a guy as busy as they come, made time for our little podcast and shared his expertise and his beautifully jovial personality to help us with an episode designed to scare the living daylights out of you. Yeah, we're talking about that asteroid strike 66 million years ago that wiped out the dinosaurs. Boiling air, massive fireballs raining from the sky, shockwaves traveling so fast they flatten everything in their paths, and massive tsunamis like something out of a nightmare. Kirk's going to walk us through all of that today, ladies and gentlemen, and boy, is it going to be fun. We're also going to be breaking down our song Chicxulub track by track. That song is named for the site where the asteroid actually struck 66 million years ago. So get yourselves ready, you guys. We have got a fun episode planned for you. The Amoeba People Podcast presents Mass Extinction. All right, we're going to break down our song Chicxulub. And oh my gosh, as we do, there's somebody else here with me. Ladies and gentlemen, who is it?
Oh my gosh, who is it?
It's you, Ryan. It's Ryan Mosley.
Hey, what's going on, guys?
Bass player of the Amoeba People.
Thrilled to be here today.
Vocalist extraordinaire, of course.
Well, you know, I have my moments.
Yeah, man. Thanks for coming out here.
And thank you. It's a pleasure. It's an honor. It's an exciting moment in time to be here with you today on the Amoeba People Podcast.
Gosh, that was super beautiful.
Thanks, man.
And also because you're on this podcast constantly, but not necessarily face to face on the microphone like this.
True that.
So.
I'm behind another microphone in another place.
Exactly. And our commercials, for those of you who are fans of our commercials, those are done by Mr. Ryan Mosley.
Yeah. Turns out those aren't actual advertisers giving us money.
Right. And Ryan and I tend to write those spots together, and then he takes them and then he just morphs them into the magic that they become.
Nice.
And
it's a lot of fun.
No, we did do one together, though. We did the bad Scottish accents together.
That's true. We did bad Scottish accents together, and it was pretty bad.
That was the Ray Troll episode 3, if you want to go back and listen to that. But I think actually my bad Scottish accent is worse than yours.
I mean, it's shades of gray, but they're all worthy of the title "bad Scottish accent."
I'm going to go out on a limb here, and I'm going to say that yours is actually quite good.
It can be, but then as time goes on in the recording, I'll kind of forget what I'm doing, and then
it's because I'm because I'm injecting my bad Scottish accent.
I don't know.
I'm pulling you away.
No, I'm not sure if that's what's going on, but yeah, we have our highs and lows.
That's right. So, okay, well, Ryan is here because we're going to break down Chicxulub, and this song has a huge contribution from. Well, actually, I think this song has a ton of all three of us.
A lot of contribution from all the Meebs.
Contribution. And so, since we're going to get into your parts in a bit, let's go ahead and talk about Dustin, our drummer, and talk about his parts first. This stuff is awesome. Because I think what happened was we were rehearsing the song and we were getting ready to record it, and he was hearing all the percussion that was going to be needed as we were rehearsing it just as a 3-piece, guitar, bass, and drums.
Yeah.
And so then he came up with all these different parts, and he knew what was going to need to go where. It was just a matter of giving him enough time and track space, and he did. So let's hear some of his glorious insanity on the drums.
Perfect. There's all kinds of just various pieces and bits that he puts together just to create this amazing layered funnel cake of drumming beauty, percussive perfection.
Funnel cake, I love it. So now we're going to hear Dustin's whistle track. We're going to throw the whistle track in there, and you know why we're going to do it, because he's laughing the entire track. Here it is. Oh my gosh. This is so great listening to all that laughter.
It's one of my favorite sounds in the world.
Seriously. We had so much fun recording the whistle track that night. I mean, oh man. Okay. Well, now we're going to bring in myself on guitar and Ryan Mosley on bass. Here we are.
Oh yeah.
Man, that is some good bass playing, Ryan.
Thanks, man. I appreciate that.
It's beautiful stuff, man. So, and you know this guitar run that goes like this one here?
Yeah.
Yeah. What a little half step
nice
thing.
Little line there. Beautiful.
Nice. Well, I've got a question for you about that. Let's do a little quiz.
Okay.
All right. So, who did I steal that guitar run from? Did I steal it from A, the Beatles, B, Captain Beefheart, C...
Yeah, I'm going to stop you right there, Ray. This is beyond ridiculous. Everyone knows that line is from Mel Torme and Bob Wells, that one Christmas song.
Well, I'm impressed that you knew that.
I mean, who doesn't? Does somebody not know that? That's so obvious.
Yeah, that is actually stolen from the Christmas song made popular by Nat King Cole, written by Mel Torme and Robert Wells, and now pretty much ruined by every person who puts out a Christmas album since
annoying.
then. But yeah, I learned that years ago out of like a Reader's Digest songbook, that little guitar run that's in there. And ever since then, I was like, I want to put that in a song somewhere. And it just fit perfectly in Chicxulub. So what do you know?
Big payoff. Worked out very well.
Now, speaking of fitting perfectly into Chicxulub, we're going to listen now to those tracks with Ryan Mosley's background vocals.
Ooh, yeah.
And, these are so amazing, the way he stacks and layers them. Here they are.
Nowhere to run. Do 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 wop, doo wop, doo wop.
Nice. Oh man, I love those background vocals. You know, like the song, because Chicxulub is a specific location, but it had a global impact. The song also kind of takes on a global vibe as well. And
For sure.
with the the guitar run from the Christmas song, with the whistles coming from Brazil, and rhythms from the classic jazz tune called Brazil.
Right.
But then we also got inspiration from Burt Bacharach's South American Getaway, from Butch Cassidy and the Sundance Kid for those vocals, right?
Absolutely. Yeah, when you shot that over to me to check out for inspiration, I listened to it a few times and immediately got the vibe and kind of just triggered in my brain what eventually came out as the background vocals for the song. I just kind of toyed around with different ideas, threw some layers on it, some harmonies and stuff, and I have to say, I think it came out okay.
Came out incredible. I mean, this is probably my favorite song on the album, but those vocals are my favorite tracks on the album.
Nice.
No question.
Wow, that's high praise. I appreciate that. I mean, I definitely had a blast making them, and I think it came out good.
Yeah, man. Thanks for being here, dude.
Well, thank you, man.
Really
It's
appreciate
a pleasure.
Yeah, and we're going to hear the completed version of Chicxulub from our album, The Fossil Record, at the end of this episode after my interview with Dr. Kirk Johnson. But Ryan, since you're here, man, why don't you throw it over to our sponsor?
I would love to. Hey, folks, please stay tuned for a word from our sponsors.
Hello, and thank you for calling the Mass Extinction Hotline, where we help you choose your mass extinction event. Please select one of the following causes. For massive volcanic eruptions, press 1 now. For extreme glaciation, press 2 now. For a devastating asteroid impact, press 3 now. You have selected a devastating asteroid impact. Now please choose from the following geologic boundaries. For Permian Triassic, press 1 now. For Cretaceous Paleogene, press 2 now. You have selected the KPG extinction, caused by a devastating asteroid impact on the Yucatan Peninsula. Once again, thank you for calling the Mass Extinction Hotline.
This time of year, I love a good ghost story, but inevitably I get asked the question why I love ghost stories if I'm skeptical when it comes to the actual existence of ghosts. My response is that you don't have to think Yoda is real to enjoy Star Wars. And thank goodness Jar Jar Binks isn't real. Anyway, when I have been shown pictures of so-called ghosts by people, the ones that make the rounds on the internet where a family's posing in front of a window and in the window is some freakish-looking girl. But the thing is, these supposed sprites are always wearing some kind of old dress from Little House on the Prairie or something like that. So for me, Carl Sagan's baloney detection kit springs into action, and I begin to wonder why we never see ghosts in Adidas tracksuits. I mean, seriously, in these online photos and videos that people share, you never see them in an Adidas tracksuit. Why don't we see them in a Rolling Stones t-shirt or a Yankees cap or a pair of Ray-Bans? They're always in clothes from the 1800s, but never in a Taylor Swift t-shirt and a hair scrunchie. Surely, though, with the population explosion of the last 100 years, there should be more and more modern ghosts wearing modern clothes. And by the way, why aren't there any ghosts with mullets? But that doesn't even address the question of where do these ghosts get their clothes? If ghosts are made of pure energy, as one person told me, then how are they able to hold up a Laura Ingalls Wilder dress on their wispy, non-material ghost shoulders? So I love a good ghost story, but if I want to be truly terrified, I talk to a scientist who can detail the reality of this amazing but frequently terrifying world we live in. Okay, it's time to say goodbye to the theremin. See you later, theremin. It's such a great instrument. As I mentioned earlier, Dr. Kirk Johnson, director of the Smithsonian's Natural History Museum, knows a ton about a genuinely terrifying event, the famed KT extinction. I asked him if he'd be willing to talk to us about the truly scary stuff, and his response?
I'm on board with death and destruction.
That's so awesome. So, well, since he was on board, I decided to jump right in. So I wanted to know what's the deal with it's the KT boundary, but it's also called the KPG boundary. We call it the KPG boundary in the song because we thought that was the updated version. But I just asked Kirk to clarify.
We used to call it the KT boundary because of the Cretaceous Tertiary boundary, but then the Tertiary kind of got renamed out of existence, and the Tertiary was broken up into two chunks, the Paleogene and the Neogene. So people said, well, let's call it the KPG boundary. And in science, you do have names get changed, like animals' names get changed and other names get changed, but you can also use the old names. So it's not inaccurate to call it the KT boundary. And basically you'll find older people call it the KT boundary and younger people call it the KPG boundary. Makes no difference. It's the exact same thing, and they're just different acronyms to the same thing. It's the boundary at the end of the Cretaceous period. And what makes it such an interesting boundary in geologic history is that it's the only boundary we know that happened in an instant. Because it was the asteroid that struck, and the asteroid took 2 seconds to strike. So it's arguably the only global instant thing that we know about. And it was instant. I mean, 2 seconds, and kaboom, and it affected the whole planet. So if you think about catastrophes, they're usually local. They're not global. If they're global, they're not abrupt. But this was a global, instant catastrophe.
I hadn't thought about it that way. You know, the fact that most catastrophes are local and not global. And so since this one was global, I wanted to know, like, what would that day have been like around the world?
And so we know a lot about it now, and we know where the crater is, we know how big the crater is, we know where the distribution of the debris is. So, and people have observed actual impacts, like the Shoemaker-Levy impact, which happened on another planet in our solar system, was actually observed. So a lot of this stuff we have a pretty good understanding, and these things are moving fast. Like an asteroid that caused the KT boundary was moving at about 20 times the speed of a rifle bullet. So it's a hypervelocity, super fast thing. It's big too. It's about 6 miles in diameter. So imagine a thing that's really big, moving really fast, but it's relatively small relative to the size of the Earth. So it's like driving a truck into a wall, because no matter how big the truck is, the wall is so much bigger that the truck just bounces off. Like, not a wall, but say a mountain. You drive it into the side of the mountain, right? So the thing is traveling so fast that when it comes towards the Earth, it passes through the atmosphere in a matter of seconds because it's going so fast. It didn't like slowly come and arrive. It passed through in a matter of seconds. So big, it pushed the atmosphere out of the way. You know, the air gets pushed out of the way, which effectively brings outer space down to the Earth's surface at the moment of impact. Now, the moment of impact is just a split second, and the energy of that thing causes an immense explosion. They call it a billion Hiroshimas. If you think about that, 1 billion Hiroshimas, hard to even conceive, because Hiroshima is hard to conceive of, but a billion Hiroshimas. And several things happen almost exactly simultaneously. First, the impact causes this massive explosion. So obviously if you're near it, bye-bye. And then the energy gets plowed into the Earth, and there's a hole that's created that's about 15 or 20 miles deep. So imagine a hole that deep and many miles wide, and everything that's in that hole is getting melted or vaporized or shattered. And eventually all that energy gets into the Earth enough that it stops and it gets rebounded back out. So if you were standing at ground zero the second it hit, you would just be vaporized, but the rock beneath your feet, miles beneath your feet, was being melted, and then that molten shattered rock comes blasting back out of the hole, and it's out of the hole in the ground, but it's up into the hole in the atmosphere. So that stuff effectively goes into outer space immediately. So you're spewing out this giant volume of molten rock, melted dinosaurs, all this stuff.
Yeah, you heard that correctly. Melted dinosaurs. It sounds absurd, but of course it's actually what happened. So just take a moment to let that sink in.
Up into the space, and a lot of it just got launched off into outer space and went away. Stuff would land on the moon.
Okay, pieces of melted dinosaur landing on the moon. It just keeps getting better and better.
And some of it rained sideways, and some of it blasted up and got into low Earth orbit and was pulled back into the Earth from the other side of the Earth. So you have all this going on, but the immediate thing is the explosion and all the downrange effects of the explosion. Of course, huge earthquakes because it's smashing the Earth really hard. So magnitude 11 earthquakes. And it happened in a shallow sea that might be only 200 or 300 feet deep. So a 200-foot deep sea that's hit by a 6-mile wide rock, it's like throwing a cinder block into a mud puddle, right? Because the water is effectively not even there. But the second the hole is created, the water is around wants to rush into the hole. Meanwhile, all that debris that's blown out is going around the Earth, around the outer orbit. As the Earth is spinning underneath this stuff, the stuff starts to go back it gets pulled back towards the Earth. And as it comes back towards the Earth, it heats on re-entry like anything entering the Earth's atmosphere. So the sky heats up to say 350 to 400 degrees, like a broiler oven. So hours after you've created this huge hole, melted everything, blown junk everywhere, all of a sudden, on the other side of the planet, the sky turns up to 350 degrees and becomes incandescent as all these particles are raining in, like millions and billions of shooting stars, but so many that the heat is radiating down from the sky. So let's say that you were, 1,000 miles away from the impact, you probably would have been killed by the initial explosion. But if you are 10,000 miles away from it, there's a giant tsunami coming your way and a major, huge earthquake coming your way. And in a little bit, the sky is going to turn up to 350 degrees and bake you from above. And this is all happening in the first couple of hours, right? So it's a really, really bad day.
Yes, of course. In fact, next time you hear a little kid complaining that this is the worst day ever, you can say, well, actually, there was a much worse day. Anything
big walking around was probably killed on that day. Like you're a dinosaur walking around in North America, it's just like the blast is going to get you. If the blast doesn't get you, the wave is going to get you. If the wave doesn't get you, you're going to get baked a little bit later. So how do you even survive is an interesting question, right? And then the question is, we don't see any evidence of any animal that's larger than a raccoon that lived on land surviving. If you were a person-sized animal walking around, bye-bye, because and why did the raccoon animals survive? Well, raccoon-sized animals might be animals where a few of them were living in burrows somewhere or underground. It looks like if you lived underground or had burrows underground, or if you lived in shallow fresh water, both of those things would shield you from that heat coming in. And of course, the heat sets things on fire, right? So you turn the oven up, you start burning the forests. So even if you were living underground, suddenly the forest above you is burning now. So that could be problematic for you as well. So we look at the number of species that went extinct, but every species, when you make a species go extinct, that means you've killed every single individual of that whole species. So we lose a lot of, almost probably everything walking around, almost all of it got killed, but in some few cases there were individuals of a species that were underground or underwater that survived that first day or first few days.
Okay, so let's say you have burrowed down, you've been underground, and after this catastrophe happens, you crawl out eventually. What do you see?
You stagger out into this world that's been completely shaken, fried, toasted, exploded, broiled. And there's a lot of stuff in the atmosphere. So much stuff in the atmosphere that you're raining out acids. You're getting a high-level acid rain because of all the particles of sulfur that were up from the sulfate rocks, bearing rocks. And there's so much dust, the sun's not getting down. So it's dark, and it's raining acid after you've been broiled. And eventually then there's enough CO2 in the atmosphere that the climate starts to warm up over a period of many hundreds of years. So you got this whole series of events that wouldn't have happened had the thing not hit. But when it hit, it just rained all that trouble down. And so the forest fires start to burn the terrestrial organisms. Out in the oceans, the dust in the air blocks the sunlight, so all the phytoplankton can't get sunlight to reproduce. And that crashes the surface photosynthetic plankton, which are the base of the marine food chain. And so you get a cascading effect on the marine food chain, which kills the oceans. So a lot of marine animals, even though they're in deep water, like the food they would normally eat disappears. And animals like ammonites, really widespread, beautiful coiled marine relatives of squids, they don't survive the boundary. And the big marine reptiles, they don't survive the boundary. And the big flying reptiles, they don't survive the boundary. And the dinosaurs, they don't survive the boundary. But all the mammals that were medium sizes, probably the only reason they survived is they were small. And the ones we see that survive are, possum-sized or smaller. So the mice and the rat-sized animals, they weren't mice and rats, they weren't even rodents then, there were rodent-sized mammals out there. They're the ones that are staggering around the next couple days going, what just happened?
Next, I asked Kirk about that boundary itself. Like, did some dinosaurs make it past that and then die off? Or is it just a hard and fast, here's the KT boundary and no dinosaurs after it?
Right. So, you can now go out and test this thing. You can go and find a place where there's layers of rock, and there'll be a layer that's about as thick as your finger that has the debris from the asteroid in it. And we've found that in over 300 locations around the world, both in places that used to be the bottom of the sea and places that used to be on land. And wherever you find that, you can look at the rock right below it, and you can look at what are called microfossils. So on land, what you look at are the remains of fossil plants, and plants produce pollen or spores. And they're tiny little things. They're like 100 microns in diameter. But even if you go out into like your yard, take a little bit of your soil, and take the soil and dissolve it in hydrofluoric acid, which will dissolve the soil. It'll leave the organics behind. You'll see tens of thousands of pollen grains and spore grains. And you can say, well, that one's a fern, that one's a pine tree, that's a rose bush. And those pollen grains tell you what's in your backyard. They're just lying there in the ground. And pollen grains are made of this material that's super resistant to acid and desiccation called sporopollen. It's like a bioplastic, essentially.
And this is where I really began to see how his background as a paleobotanist comes into play when it comes to determining the age of all of these things.
And those pollen grains last forever. So if I go to a place that has a dinosaur fossil, take a chip of mud, dissolve it in acid, I can tell you what the forest was like where that dinosaur was living. A chip of mud, the size of your fingertip, will give me 10,000 pollen grains. And I just count them up and go, yep, there was like a bunch of monkey puzzle conifers and some ferns and a bunch of cycads. And I can tell you what the forest looked like. So if you look at the little chip of mud right below that little finger-thick layer, you can see the forest that lived with the last dinosaurs. You look at the chip of mud just above that layer, half of the species are gone. Now, this is plant species, which means you killed all the individual of that species of plant. That's like killing every rhododendron in North America and every pine tree in North America. So there are some plants that survived, but those might have been just, small groups of places where they were sheltered from the blast by a rock wall, or, there's lots of places where you might get a few things to survive. And in the plant world, the plants that lived in swamps did better than the plants that lived on dry land. Something probably having to do with the water, protecting them from the heat in some kind of way. But when you look for dinosaurs above that layer, you just don't find them. Now, the question is, and we don't know the answer to this question because we only have places that have dinosaur fossils right below the KT boundary, mainly in North America and in northeastern Asia and a little bit now in South America. But we haven't found that precise layer in land deposits in Africa yet, or we haven't found it in Australia yet. So we don't know what happened in the places where we don't have the rocks to tell a story. But it looks like, New Zealand, there's dinosaurs below, not above. There's enough places around the globe. It's like, it looks global. But the caveat is we haven't sampled the whole globe yet.
Okay, since this is our Halloween-ish episode, I asked Kirk, what is the scariest story from the KT extinction, or the KPG extinction? At least in his opinion, what really kind of freaks him out when he thinks about it?
Well, the one I like, actually, is that if you go to Belize, there's a quarry that has some of the debris that rained out of the crater, which is several hundred miles away. And the debris includes blocks of rock that are 300 feet in diameter. So the impact is not only just sending molten stuff everywhere, but it's actually throwing building-sized rocks hundreds of miles. Just to give you some sense of it. So if you're like minding your own business and all of a sudden a building lands on you that was lofted 300 miles, that's like, I like that one.
Well, that is terrifying. and humorous at the same time, or maybe humorously terrifying, whichever you prefer. But it got me wondering, about what other asteroids might be out there. Which ones should we be concerned about? Is there another Chicxulub-sized asteroid out there on a potential collision course with Earth?
As the solar system ages, the really big ones get sucked out of circulation because they get pulled by gravity into various planets. It might be Jupiter or Saturn or the Earth. But our planet's sort of being vacuumed by the big planets, so that as more time passes, the fewer big ones there are. So it would have been more dangerous 100 million years ago than it is now in a general sense. But there's still some big ones out there. And were they to hit Earth, the question is, how big of an asteroid does it take to really ruin your day? Because the one that went into Russia a couple years ago,
right?
That was the size of a school bus. So, and it on entry, it blew out windows coming in. It was going big, and it blew out windows, and it exploded when it landed, and it was pretty bad. But, it didn't cause the end of anything. It just was a big rock coming in really fast. And Meteor Crater in Arizona, that's a mile-wide crater. That was probably 100-yard wide asteroid impact that hit 50,000 years ago. So we're forever looking at for new asteroid impact sites or old ones, trying to date the crater and look at the size of the crater. And the big question is, how big does the impact have to be to have a global effect? And clearly the one that caused the KT boundary was big enough to ruin the place, but it didn't kill everything. It killed about half of everything, whereas a smaller one would kill maybe much less than half of everything. So it's definitely worth paying attention to, because if you had one the size of, say, like the crater that made Meteor Crater in Arizona, if that hit in New York City, that would be a problem, right? You'd have a mile-wide crater in the middle of New York City. It's the equivalent of a big nuclear kind of thing.
So let's jump right into that asteroid hypothesis, the one that was proposed in 1980 by Luis and Walter Alvarez, a father-son team, that first suggested that it was an asteroid that might have wiped out the dinosaurs. And you know how you hear in school that when a scientist comes up with a new idea, it's the job of the other scientists to try to disprove it and say, boo, and then if they can't disprove it, then, maybe it's a valid hypothesis. Well, I never knew, how much do scientists really do that? Are they really, cantankerous and always trying to contradict each other? Well, guess what? Kirk Johnson did just that. He heard this theory and he said, boo. Okay, maybe that's a little bit of an exaggeration, but he immediately went out to test it. And here's what happened.
Initial discovery was in 1980. A paper was published where some scientists in Berkeley, California, discovered 3 sites where they found the layer of debris that looked like it had asteroid metals in it, platinum group metals. And they made this crazy hypothesis that an asteroid caused the extinction of the dinosaurs. And at the time, we were all like, come on, that's not happening. Just 3 sites, a little bit of powder, could be something else. But they proposed the hypothesis, and we rushed out to test it. And I ran out myself to test it, and I went to North Dakota where there's nice geologic layers, and I found the layer. I was the first one to find it in North Dakota. And it was exactly where they predicted it was, right above the last dinosaur. I was like, they might be right, actually. And then we kept testing it through the 80s, and pretty soon it was like, no, they actually were right. And in 1990, we found the asteroid impact crater itself. It's like, yep, they were right. And now it just kind of keeps piling on. It was a really cool idea that seemed so implausible, but it was actually a real idea. And once that concept existed, then it's like, okay, now there's an existential threat from outer space that nobody was thinking about.
In our 3rd episode of this podcast, our episode with the paleo artist Ray Troll, Ray, who is a good friend of Kirk Johnson's, told me about a time where he and Kirk were traveling together and they discovered that iridium layer. And so I asked Kirk about that moment and what that was like.
Well, that's true for so much of science. When you're actually at the cutting edge of discovery, and you make a discovery and you actually realize you've made one, because often you make a discovery, you don't realize you've made one. That happens all the time because you have to know a lot to know that something's unusual. And in the case, when I found the first KT boundary, that was in the summer of 1986. And you can't recognize the platinum metal by looking at it. You have to do it in laboratory tests. And you can't recognize those fossil pollen grains by looking at them with your hand lens because you need a laboratory test. So what I was doing is I was going around and I was cutting vertical sections through various layers of rock and sampling layers and sending one set of samples to a nuclear lab at Los Alamos and one set of samples to a pollen lab at the USGS in Denver. And then the two independent analyses would come back to me and I'd say, is anything unusual here? And so I'd sampled a lot of places, but I sent 2 suites of samples. I'd gone to a place where I'd seen some dinosaur bones. I thought, this is the last dinosaurs. And I took a series of samples and sent them off to a guy named Carl Orth at Los Alamos and a guy named Doug Nichols at USGS. And I remember they both sent me back their results independently. So Carl Orth goes, yeah, you actually have an iridium spike here. I can see this iridium platinum group metal spike. There it is. And then I waited for Doug's result. And Doug's like, yep. And you actually have a pollen extinction horizon. I'm like, is it the same layer? And I lined them up. And it's like the same layer. So I had the layer, and so I didn't discover it until the analyses came back. But when Ray and I were driving around out in North Dakota in 2000, one of the features of the impact is that it melts the target rock and sprays molten rock into the sky, which cools into glass. So for a while, it's raining blobs of glass, marbles, beads, plate windows. Like the sky is raining glass. And those little glass balls are called tektites. And the little ones are called microtektites. If you're really close to the impact site, you can get great big tektites the size of cars. But you get further away, they get smaller and smaller. And we went to the site in North Dakota, which was near where I'd found the original boundary. And I was trying to show him the layer where I'd sampled, and we dig into it, and we're looking at the layer. It's about as thick as my finger. And my eyes focused, and I realized the layer was composed of tektites. I could see them with my naked eye. So no one had ever found those things in North Dakota before. And there were the little glass beads that were blown from the crater in Mexico and shot all the way to North Dakota, landed on the landscape, got buried, then got exhumed, and we encountered them. And so that was a moment where we absolutely knew the second we saw them that we had made a discovery. And that was awesome.
And I mean, isn't that why scientists get into this line of work? I mean, that is science right there. It's that process of discovery. And the moment you make a discovery like that, that's just gotta be incredible. And kind of arcing back toward our Halloween theme here, I wanted to know one very important thing. What scares Kirk Johnson? I mean, this is a guy who's been out in the wild and every location you can imagine, but what's the one thing that really scares him?
Well, I generally find that the out of doors is a really lovely, safe place. Like you're not usually getting attacked by animals and that kind of stuff, but occasionally you do, and there are definitely people who have been attacked by bears while they're out doing geology, or we see a lot of snakes, but snakes are usually not that big of a deal. Although one of my friends just got bit by a rattlesnake in San Francisco recently, so I find in general that I feel less afraid of things when I'm out in the middle of nowhere than I'm in the middle of cities. Put it that way. Like the most dangerous animal on the planet is the human animal for sure. But there's also, you can definitely fall through ice and fall off cliffs, and there's a lot of things you can do that are kind of stupid things. I mean, that's kind of it's like how lucky do you feel, and what kind of situation do you put yourself into when you're out there that cause problems. But by and large, it's still way more dangerous to drive in a car in a city than it is to go to a remote place and look for fossils.
That is pretty great. I mean, I'm asking Kirk Johnson, a guy who basically is an adventurer and who has made a name and a career on those adventures, and who is an expert on extinction and asteroid strikes and dinosaurs and paleobotany. And I ask him, what truly terrifies you? And he says, city life. I mean, how great is that, and true, actually, when you really think about the statistics. So it's great to get that kind of perspective. And so I just want to take this chance to thank Kirk Johnson for being on our show today. What a fantastic guy, huh? I'm so glad that you got to hear that jovial personality I was talking about, and then the incredible brain and knowledge base, and just, able to just pull from that deep well of experience and knowledge is just fantastic. I mean, you can ask the guy anything. So So I want to plug a bunch of Kirk's work here. So, of course, he is the director of the Smithsonian Natural History Museum. So if you get out there, check out their new Deep Time Fossil Hall, which has been in the works for years, and Kirk oversaw that. And don't forget, of course, he's got another new NOVA special coming out in 2020. That one's called Polar Extremes. It sounds super fascinating. I am one of those NOVA nerds, I admit it. And, of course, Cruising the Fossil Coastline was his most recent book with Ray Troll, which just came out a year ago. And speaking of books, he also has The Paleo Art of Jay Maternis coming out, actually, I think right now, as we're posting this podcast. And Jay Maternis is the paleo artist who did those murals at the Smithsonian Natural History Museum where Kirk works in Washington, D.C. And, also make sure if you don't have a copy of Cruising the Fossil Freeway, that was the first book that Kirk did with Ray Troll. If you don't have a copy of that, you've got to just go get that right now, too. Some of the best geology food analogies you will ever come across. Just brilliant stuff. Kirk just has such a great way of breaking things down to their simplest components and making them accessible. It was just such a thrill to have him on the podcast today. So, since the Amoeba people are shameless, of course, I did ask him if he would introduce our song.
This is Kirk Johnson, director of the Smithsonian's Natural History Museum, and this is Chicxulub by the Amoeba People.
Chicxulub, there is a crater down in Chicxulub. Don't be a hater, brother, don't be rude. It's only Chicxulub. Chicxulub, there is a crater down in Chicxulub. 100 million megatons of doom came down with a boom. Ooh, it happened in the late Cretaceous, and its impact was bodacious when that asteroid hit. Ooh, a giant fireball lit up the sky. Oceans boiled and the creatures fried, and there was nowhere to hide. Mega tsunami scrubbed clean every shore in the vicinity of the impact site. It was unlike anything those dinosaurs had ever seen. Chicxulub, what a disaster, brother. Chicxulub, destructive like no other. Chicxulub, oh what a bomber it was. Chicxulub, apocalyptic it was. Chicxulub, nothing cryptic, just a crash and boom, and then planet-wide doom. Oh yes, it slammed into the Yucatan, which became a giant frying pan, cooking the atmosphere. A cloud of CO2 blocked out the sun. Ash and fire rained on everyone, and there was nowhere to run. The only survivors were those who could dig or dive to the depths of the sea. A dubious distinction that was caused by mass extinction in that fiery global foundry called the KPG boundary, where the dinosaurs they were dying no more. Yeah. Chicxulub, there is a crater down in Chicxulub. Don't be a hater, brother, don't be rude. It's only Chicxulub. Chicxulub, it seems so docile down in Chicxulub. Nothing but fossils now are left of those creatures long gone. Forever, those creatures are gone. Forever.
Just waiting for that last whistle there. Thank you for tuning in to the Amoeba People podcast. My thanks to Kirk Johnson of the Smithsonian Natural History Museum for being such an incredible guest today. If you like our podcast, please give it a rating on Apple Podcasts or wherever you download your podcasts, and write a review. That's how people find out about it. That's how it kind of moves up in the rankings, and then people will see it, and hopefully more people will listen to it and share it as well. We also have a YouTube page if you'd like to follow us on or subscribe to us on YouTube. We've got a bunch of science music videos up there, as well as episodes of this podcast. You can email us through our website at theamoebapeople.com. You can follow us on all social media platforms, and tell people. Word of mouth helps get the word out about this podcast. So just tell people about our podcast and share it with them. If you want to support us financially, we do have a Patreon page, and thank you to those of you who have already done that. Super helpful. We would love to keep doing this show well into the future. And finally, happy holidays. Halloween, everybody, huh? This was our Halloween-ish show, and so we just want to say steer clear of asteroids out there. Be safe, okay? You never know when a KT-sized asteroid might just hurtle down on October 31st as you're trick-or-treating. So be careful out there. Until next time, onward!